This is going to be Euclid Book 7, proposition number 6. Here's the diagram. Study this, pause it, take a picture of it. I don't care what you do with it. Alright. Let's go through the proof real quick. It says, if a number be parts of a number, and another be the same parts of another, the sum will also be the same parts of the sum that the one is of the one. Now I know you're sitting there going, what in the world is he talking about now? For let the number AB be parts of the number C. Well, AB in this case is going to be 6, and C is actually going to be 9. Okay? And another DE be the same parts of another F that AB is of C. Well, in this case, DE is going to be 14, and F is going to be 21. Now, what is he talking about here? Well, 6 is 2/3 of the parts needed to make 9. Okay, so each part of C is 3. And we have 2 parts of C in AB, because 3 plus 3 is what? 6. So we have 2/3 of the parts of C in AB. Okay, and the same is true of DE and F. Alright, the parts of F are 7. Well, there are 2 parts of 7 in 14. How do we know this? Because if you add 7 plus 7, you get 14. So there are 2 parts of F in DE, because DE is 14 and F is 21. Okay. So let's go back into this. For let the numbers AB be parts of the number C, which we've done, and another DE the same parts of another F that AB is of C. Well, if AB is 2 parts of C, then DE is also going to be 2 parts of F. Okay. I say that the sum of AB and DE is also the same parts of the sum of C and F that AB is of C. We're going to prove this. For since whatever parts AB is of C, DE is also the same parts of F, which we've already established. Therefore, as many parts of C as there are in AB, so many parts of F are there also in DE. We've just established that. There are 2/3 of the parts needed for C in AB, and there are 2/3 of the parts needed for F in DE. We've already established that. Let AB be divided into the parts of C, namely AG and GB. Well, AG is the length of 3, GB is the length of 3, DH will be the length of 7, and HE will be the length of 7. AG is 3, GB is 3, DH is 7, HE is 7. That's what we're doing here. Okay. Thus, the multitude of AG and GB will be equal to the multitude of DH and HE, which we've established. And since whatever part AG is of C, the same part of DH of F also. So, AG is 1 part of C, and DH is 1 part of F. Therefore, whatever part AG is of C, the same part also is the sum of AG, DH, of the sum of C and F, which we proved in Euclid Book 7, proposition number 5, which was our last video. For the same reason, whatever part GB is of C, the same part also is the sum of GB, HE, of the sum of C and F. Okay? And we have proven this by Euclid Book 7, proposition number 5. Now you say, well, why don't you clear that up for us? Okay. The sum of AG and DH, okay, AG is 3, DH is 7. 7 plus 3 is 10. And the sum of C and F is 6 plus 21. Well, 21 plus 6 is 27. Okay? No, I'm sorry. Scratch that. C is 9, F is 21, so 21 plus 7 is 30, and 10 is a third of 30. Okay, so I messed up there. I'm sorry about that. And we can go on with the GB. Okay, whatever part of GB is a C, well, GB is 1/3 of C. So GB plus HE. Well, GB is 3, HE is 7, so that makes 10. Okay, and C of course is 9, and F of course is 21, and 9 plus 21 is of course 30, and of course 10 is 1/3 part of 30. Therefore, whatever parts AB is of C, the same parts also is the sum of AB, DE of the sum of C and F. Well, what's AB? AB is 6, DE is 14. 14 plus 6 is 20. Okay? What's C? It's 9. What's F? It's 21. Well, 9 plus 21 is 30. Okay? So, is it 20, 2/3 of 30? Of course it is. And that's how we prove the proof. And that's all that's needed. Alright. I will tell you more in a future video. Stay tuned.